Today we'll be solving special linear systems. Some will have a solution of one solution, some will have no solution, and some will have infinitely many solutions. Well, first look at one solution. Let's go ahead and solve this using a graph. When I solve using a graph, I see that the two lines intersect at exactly one spot. So that's why it's one solution. It has one point of intersection. And in this instance, it's 3, 4. Let's also look at solving for one solution. Here you can use the substitution or the elimination method. Okay, this is written in standard form, so the elimination method is probably the most efficient method. Again, we got our solution is -3, 4, so one solution. Sometimes when we solve linear systems, we'll come up with a system with no solution. So go ahead and graph this linear system. And as you can see, when we graph them, they are parallel lines. There is no solution because the lines never intersect. We can also see what makes them parallel is they have the same slope. They each have a slope of 1. So if you're solving a system and each equation has the same slope, you can stop right there and you'll know it's no solution because they're parallel lines. Go ahead and solve this system using either substitution or elimination. The best method here would be the elimination method. And as you can see, we come up with a false statement. 0 is equal to 14. That's not true. So since it's not true, there's no solution. Again, they're parallel lines that never intersect. And the third type of solution we can come across are called infinitely many solutions. So go ahead and graph these lines. And it's the same line. When we solve for y, we get the same equation, infinitely many solutions. So if we compare the two equations, I had a 1 and then a -2, a 3 and then a -6, and a 6 and a -2. So the difference between these equations are the same equation. The second one was just we took the first one and multiplied by a -2 to get the second equation. So go ahead and solve using substitution or elimination on this one. And in this instance, since the y was already isolated, substitution may have been a better way to go. And again, here we end up, our variable 0 disappears, and we have a statement that -2 is equal to -2, and that is true. So that is infinitely many solutions. We can put any number in there and it'll work.